So if I go back to the results, let's try one of these that are at a little lower efficiency. Say maybe this one that's at 68%. If I look at the graph, I can see the same kinds of things on this graph. It's a casing that is 16-inch diameter impeller size nominally. It's got an input of 10-inch pipe and an output of an 8-inch pipe nozzle. And we'll notice that we're operating down here really at sort of the low end of the operating flow rate range. So here we are at 100 liters per second. The sweet spot on this one is more up in here around 200 liters per second. So this would really be overkill. This is a bigger pump than we really need. And we're actually operating down here at the very low end of its reasonable flow rate. So probably not a great choice. Efficiency's lower, down more in the 68% to 70% sort of range. But again, we've got separate head flow curves for different sized impellers that we could put in. And this is what they're suggesting, is that we take this 15.5-inch impeller and that we just mill a little bit off of it to get a slightly smaller impeller to better fit our particular operating condition. So we've got two possibilities that are right up at the top of our efficiency levels, up around 80%. One is this KS pump and the other is this TA 1548 pump. They're both using about the same amount of power and they've got similar characteristics otherwise. Let's go look at this TA 1548 pump. If we look at its curve, again we see the same kind of thing going on here. This is a little bit bigger pump. It can take a larger impeller up to about 18 inches. But it's suggesting that we get in here still around the same sort of size range, around a 16-inch impeller, and we'll be operating in the same kind of efficiency area. We're in the middle of the pump curve, so that's good. We're still in here at about 130 horsepower, in between 125 and 150. And we're at a fairly low NPSH. I think it said on the spec sheet 9. So that might also work. So let's go back again and see what this looks like. Well, we know what the curve looks like in terms of the pump's performance. The instruction sheet will let us know exactly what the pump looks like if we go out and buy one to install it. So this is the kind of thing that we're looking at. This is similar to the pumps that you saw in the reality check video. It's double suction. That means that the flow is going in through here and going to either side and into the center, around through the casing like this. It's splitting from this pipe. Some's going in this side of the impeller and some's going in that side of the impeller. That means that there's no net axial thrust on the shaft, which is good. The discharge is over here on the other side where the flow will be coming out. And this is already nicely mounted on a mounting frame. So this would be fairly easy to mount in our plant or our pump house or wherever we're going to mount this. We can just bolt it to the floor. So let's go back and have a look at our other pump and see what that KS 8016 looked like. Well, here's the instruction sheet for that one. And it's a vertical inline pump, so it's not quite the same configuration as the other one. It's still got this double suction where the suction line is splitting around here and going in either side of the pump. Here's the motor and it's rotating on a vertical axis, and here's the discharge. So it's a different sort of configuration. It's a vertical inline pump instead of a horizontal pump. And let's have a look at the overall catalog data. Here's a photograph of the pump, so we can see the discharge here and the suction coming in on the other side there. So this would allow us to mount vertically, and we could support it on the floor down here to avoid having to carry all of the load of the pump on the piping. So depending on the type of configuration we're looking for, we could choose a different pump that would be hydraulically very similar on the inside, but physically different for mounting on the outside. And it's way beyond the scope of this course to be going further in picking out the hardware than to notice that there are different configurations available. And that's the sort of thing that you would develop in a full-on piping course, or that you might get from practical experience in the particular industry you're working in. So let's move back to the actual pump performance curve. So let's pick the TA 1548 as our selected pump for this task. And we've got our pump curve here. This is our model 1548. It's got a 6-inch discharge and an 8-inch suction. And we've got a lot of room here. We're operating right in the middle of the zone where the best operation will happen with this pump.